change?
Just use the ropes.
Okay. First of all, I would like to thank you to let me join this discussion to speak about the subject I'm very passionate about it, morphology transition engineering. Before moving to our discussion, I would like to introduce myself. My name is Ahmed Abdelmohsen. I had Bachelor of Science Chemistry with first class honor by Swift University in Egypt, some postgraduate study in physical chemistry, material science, nanotechnology, European Master Candidate, Oxford University, Green Nobel Film Institute, Catholic University of Leuven. I am the principal researcher for morphology transition engineering that has just published in Nature Scientific Report 5 days ago, as shown here. The content of our discussion. First of all, I will start explanation the concept of material engineering, our new expansion for material engineering, as mentioned in our paper in Nature. Then conceiving this idea, how we conceive this idea of novel sensing approach. Thirdly, supposed mechanism number one, which depends on physical explanation. Fourth, supposed mechanism number two that will be published in chemical communication. Five, catalytic deposition mechanism. Six, Abdelmohsen theory that has been published. Number one. Seven, Abdelmohsen theory number two that is under review in Journal of Material Science and Engineering. Finally, applications of our novel composites. First of all, we expanded the concept of material engineering to involve, control, and design the oriented structure of material as shown here. For instance, we can notify the morphology evolution by time. If you are preparing, for instance, nanorod by any approach, we will start with nanoparticles, then to nanorod, then to nanowires per times. Or varying their external morphology as shown in our work here. We started with zinc oxides nanorods, and then by fusions we had in the past this zinc oxide nanoplatelets crafted with M oxide molybdenum oxides. This is favorably with functionalization, doping, mixing with other material to attain the synergistic effect which enhances their properties. We already reported two examples, the main two examples, top-down approach and the bottom-up approach for preparation of nanomaterial. Our expansions is this process of sensing is a simple engineering because we build our material atom by atom, then molecule by molecule, from bottom to up until we get our final structure here: rod, particle, platelets, tubes, stars, spheres. So it's process of engineering. Here also bottom up approach, and also here bottom up approach. Conceiving here examples for our materials that has been prepared by bottom up approach, these nanostructures of metal oxides. Conceiving our novel approach for sensing nanocomposites, and also example for top-down approach. Here we are breaking the large carbon black in micro scale. Here if PPT is working, this should be divided under ultrasonication stimulus, and due to the small particles of carbon nanoparticles in the original solution, for instance water, ethanols, these carbon nanoparticles that are formed by sonication will agglomerate rapidly. So we are using polyoxometallate anions that agglomerated around the surface of carbon nanoparticles and form the cross-linked carbon nanoparticles. So at the end we got cross-linked carbon nanoparticles. On these times I was reading more about lithium-ion battery and the ability of bridge between nanostructures to allow fusion of lithium ions as a bus lanes for electrons and prevent agglomeration of nanoparticles. I got the idea of cross-linked metal oxides. But during the preparation of cross-linked metal oxide here, we were amazing about the final product, which was look like this. Zinc oxide nanoplatelets grafted molybdenum oxides. So what is this? How we got this? In a simple way, we have prepared zinc oxides nanorods by bottom-up approach by a simple way, and we got the zinc oxide with pencil-like tip. For the first time, and the pioneer work of our group is to how find a detailed and rational mechanism for our reactions or self-assembly of zinc oxide nanorods to hybrid nanoplatelets on the basis of hard and soft Lewis acid and base theory, pronosted Lowry acid base theory, frontier molecular orbiter theory, and side bending model. We supposed our novel mechanism for preparation. In a simple way, we had started with zinc oxides nanorods immersed in polyoxometallate solution or phosphomolybdic acid. Then we noticed or notified the formation of cross-linked zinc oxide nanostructures. Per time, the formation of hybrid nanoplatelets, but with grain boundary, no complete fusion. At the end, we got this well-shaped nanoplatelets. At the same time, we notified only chemical etching of some zinc